Ashwin Zeras and welcome to lab. Welcome to demo 2 of the final project. So let's go over the formulated strategy. So initially we downsized the data with a threshold of 500 samples per label. So before we do this, actually we have like uneven number of samples per label. So we are using CNN for classification and data processing. As CNN doesn't tolerate unbalanced number of labels for each class, we have gone for balancing of the samples per each label. So we have rejected samples that doesn't meet the requirement, which is a threshold of 500. So if the number of samples per label is less than 500, we simply reject that label. So after we have done this, after we have made the estimation of the number of samples per each label, we have rejected the sample labels which do not have 500 samples. So it comes down to only 5 classes with labels more than 500. So once we have got to this point, we still need to do some class balancing to make all the classes have same number of samples. So for this we are using an upsampling technique called SMOTE. So what SMOTE does is it balances the different classes. So if there are like 1,000 samples in one class, which is the highest here, it balances the other classes by making their samples to 1,000. So it's simply an upsampling technique and we achieve class balancing here. So this is done uh, right here. Right here is the code. So after we have loaded our data and labels, we use the SMOTE technique with a training and testing set. So this is the SMOTE object. Got it as an object on our data set. And then once it's done, we get the output like this. So this is up with the class balancing. So once this is done, we have to like find the prominent features. So there are like many number of features from the data set as such, nearly 200 to 300 features. So we are using a neural network to find the prominent features. This is done by an autoencoder technique. So autoencoder is used to reduce the features to a number of prominent features. It works best in the case of lesser number of samples. So here we already have found that the highest number of samples itself is 1,000 per label, and this is why we are going for an autoencoder. So it helps us select the prominent features, especially in cases where the number of samples are low. So a neural network with the autoencoder is implemented. That is here. So we have loaded our training and testing set, and then we have used the autoencoder for each. So we have 100,881, and it is reduced to 300. So this is the CNN model for the autoencoder to find the reduced number of features. So after this is done and the model training is done, the loss is found to be close to 4 exponent, and the model converges after a good amount of time. So this is the CNN loss graph which we see, and in the end it has converged. So yeah, so now we have the classes with a balanced, we have the classes with a balanced number of samples, and then we have found out the prominent features. So now this gives us a very good platform to do further clustering to find unidentified cancer subtypes. So since we have this, we'll again use a neural network and maybe try to cluster the five classes to identify unappreciated cancer subtypes, because already we have the five classes. If we further cluster deep into this, we might have a possibility of finding unappreciated cancer subtypes and their relationship with the other subtypes. So this will be done in the next week. We're planning to use the gene expression quantification data for the five labels which we have shortlisted to. So this will like again improve the number of samples and might add a few more prominent features. And again, if it is necessary, we have to do the class rebalancing again and cluster to find the unidentified subtypes. This is it for week 2 demo, and we'll be like uploading a demo next week. So thank you.